In this video, we're going to do a continuation of the solving exponential and logarithmic equations. This video has an application to that, and this is where we're going to revisit what we call the compound interest formulas. Here we can use the compound interest formulas to determine the amount of time required for an investment to reach a certain amount at a specific interest rate, or we can find the annual interest rate of an investment. So here we're going to be using some of the properties of logarithms to find out the time that it's going to take for an investment to reach a certain amount at a given interest rate, or you can use that to find the annual interest rate itself. Okay, if you remember in one of the videos that we talked about for exponential expressions or exponential functions, we had these two formulas here. For n compoundings, whether it's compounded semi-annually or quarterly or monthly or daily, we have to use this formula. A is equal to P times the quantity 1 plus R over N raised to the N times T. And then for continuous compounding, it's A is equal to P times E to the RT. Okay, so we're going to use those two formulas to solve these types of problems, like this one right here. Let's say we want to find out how long, to the nearest tenth of a year, will it take a $10,000 investment to grow to $3,600 at 8% annual interest compounded quarterly. Okay, so let's look at what's given to us. We have a principal of $1,000, and then we have an amount that we're trying to attain, which is $3,600. Then the interest rate is 8%, and it's compounded quarterly. So this is what we have given. The principal is $1,000. We're trying to reach $3,600 at 8%. Now 8% as a decimal will be 0.08. And then there are 4 compoundings if it's compounded quarterly, so n is equal to 4. Okay, now let's revisit that formula. A is equal to P times 1 plus R over N raised to the N times T. Okay, if you remember, for n compoundings, we have to use this formula. It's compounded quarterly, so we have no choice but to use this formula. Now let's replace those values into this equation. So here A is 3,600. That's going to be equal to P, which is 1,000, times 1 plus R, which is 0.08 in decimal form. N is the number of compoundings, that's 4. And then it's going to be raised to the N is 4, and T is what we're trying to find. So it'll be 4 times T. So in reality, we want to find out what T is equal to. Now let's simplify this a bit. We got 3,600. That's equal to 1,000 times 1 plus 0.08 divided by 4 is going to be 0.02. That's raised to the 4 times T. And then 1 plus 0.02 will be 1.02. So you have 3,600 is equal to 1,000 times 1.02 raised to the 4t. Now we need to get the 1.02 to the 4t by itself. It's being multiplied by 1,000, so let's divide both sides by 1,000. So 1.02 next to the 4t will be 3.6. So 1.02 to the 4t will be 3.6. Now we have an exponential equation here. Now to solve that exponential equation, we need to take the natural logarithm on both sides. So we'll take the ln of 36 here, 3.6, then ln of 1.02 to the 4t. The right side of this equation, we're going to have to use the power rule. So in this case here, that 4t goes in front of ln of 1.02. And that's equal to ln of 3.6. Okay, and I'll see I'm going to be running out of space here. So to get t by itself, we want to solve for t. T is being multiplied by 4, and it's also being multiplied by ln of 1.02. So you want to divide both sides by ln of 1.02. Okay. So that means we're going to have t is equal to this expression ln of 3.6 divided by 4 ln of 1.02. And we want to come up with a approximate answer for that. Okay, now let's see how we're going to do this in the calculator. I'm going to put the left parentheses here and then type ln 3.6, close the parentheses, and then close it again. That's the numerator. Now the denominator is going to be 4 times ln of 1.02. So left parentheses, 4 times ln 1.02. Close the parentheses and then close it again. And then press enter. And to the nearest tenth of a year, that'll be 16.2. So it's going to take 16.2 years for a $1,000 investment to reach $3,600 at 8% compounded quarterly. So that's how you would find out the time that's going to take for a single investment to reach a certain amount at a given interest rate, whether it's compounded quarterly or daily or monthly or semi-annually. Okay, now let's look at another example where we'll be using the one that says compounded continuously. Like this one. How long will it take an $8,000 investment to double at an interest rate of 8% compounded quarterly? No, not quarterly, continuously. And you want to round the answer to 1 decimal place. So here we're looking at a situation of continuous compounding. So we're going to be using the other formula, A is equal to P times E to the RT. All right, now let's look at what's given to us. Okay, we have an $8,000 investment, so P is 8,000. And we want it to double. If we're going to double 8,000, that means that A will have to be $16,000. And the interest rate is 8%. And as a decimal, that will be 0.08. And it's compounded continuously. So T is what we're trying to find. If it's compounded continuously, we need to use this formula. A is equal to P times E to the RT. That's the formula we must use. And then we replace those variables with those values. A is the amount we're trying to reach, is 16,000. That's equal to P, which is 8,000, times E to the R. R is 0.08 times T. So that's the equation that we have. And of course, this is an exponential equation, so we need to get the e to the 0.08t by itself. It's being multiplied by 8,000, so we need to divide both sides by 8,000. So we're going to have e to the 0.08t And then that's equal to 16,000 divided by 8,000. That's going to give us 2. Okay, now the only way we're going to do this, since E and Ln are inverses of each other, we'll take the natural logarithm on both sides. So we have ln of 2 is equal to ln of e to the 0.08t. Now on the right side, we'll use the properties of logarithms. Ln of e to whatever the exponent is that exponent. So ln of e to the 0.08t will be 0.08t, and that's equal to ln of 2. And then to solve for t, we need to divide both sides by 0.08. And for t, we just type in ln of 2 plus ln and then 2, close your parentheses, because you only want the ln of 2, divide that by 0.08. And then close your parentheses. Let's see, to the nearest 10th, 8.66 will be 8.7. And it'll be 8.7 years, because the time would be in years. So it's going to take an $8,000, well, it's going to take 8 years for an $8,000 investment to reach $16,000 at 8% compounded continuously. Okay. All right, here's another example that deals with compounded continuously. How long will it take an investment to reach $17,425 at an annual interest rate of 4.25% compounded continuously? And we're going to round the answer to 1 decimal place. So in this case here, let's look at what's given to us in this particular problem. We know that P is 17,425. The amount that we're trying to reach is $25,000. The interest rate is 4.25%. But as a decimal, it's going to be 0.0425. And T is what we're trying to find. It says compounded continuously in the problem, so we have to use A is equal to P times e to the RT. And in this case here, A is the amount that we're trying to reach is 25,000. That's equal to P, which is 17,425. E to the R is 0.0425 times T. So that's our exponential equation that we have here. Now we need to get e to the 0.0425t by itself. It's being multiplied by 17,425, so let's divide both sides by 17,425. Which means we'll have e to the 0.0425t, and then 25,000 divided by 17,425. And I'm going to use as many decimal places as I can. 1.43472. And then E and Ln are inverses of each other, so we'll take the natural logarithm on both sides. So I have Ln of 1.43472 equals Ln of e to the 0.0425 times t. And of course, Ln of e to the exponent is that exponent, so Ln of e to the 0.0425t would be 0.0425t, and that's equal to Ln of 1.43472. And then to solve for t, you're going to divide by 0.0425. So that means t is equal to Okay, now I'm going to do this. Press LN and then type in all that entire decimal value of 1.43472 and close the parentheses. Divide that by 0.0425, which is what I have here. And that's going to give you, we're going to say 8.5, rounded to one decimal place. So here, the time would be 8.5 years. Which means it's going to take 8.5 years approximately for a $17,425 investment to reach $25,000 at 4.25% annual interest compounded continuously. Okay, so this is how we use those two different formulas to find out the amount of time that a certain investment will reach a certain amount at a given annual interest rate, and it could be compounded in any one of the 5 different ways, either continuously, or it could be by quarterly, semi-annually, monthly, or daily. And that will conclude this particular section on compound interest.